Let's have another example of constructing our truth table. So we are asked to construct a truth table for this specific statement, P and not Q, or not P or Q. And we're asked again to use that truth table to determine the truth value of the statement, this statement, given that P is true and Q is false. So again, first, we see that there are only actually two main propositional variables, P and Q. So that means we would only have 2 raised to 2 for situations with our truth values. And that would actually just be true, true, true and false, then true, false, true, false. We have a not P and a not Q there, so I will also write them down here because it's quite easy for me to be able to find not P and not Q. Although the order is not actually necessarily important in the truth table. So you can actually have not Q first, then have P and not Q, then later on not P, then have not P or Q. That depends on however you want the truth table to be. But just make sure that the last column would be the one that is the final truth value for the entire statement. So take note that the final column to be constructed is the truth values for the entire statement or the entire proposition. So there we go. So we'll have not P, so we'll just have false, false, true, true, and not Q will be false, true, false, true. Now we can get the truth values for P and not Q. So that's P and not Q. So true and false is false, true and true is true, false and false is false, false and true is false. On the other hand, we can also have not P or Q. So false or true is true, false or false is false, true or true is true, true or false is true. And finally, we would now have P and, oops, sorry, there you go, P and not Q, or not P or Q. So therefore, this one here, these two columns here, false or true is true, true or false is true, false or true is true, false or true is true. So there, so actually, whichever the truth values of our P or Q here, it will always be true. And even if P is true and Q is false, the entire statement rather would still be true. So, it's your turn. Pause the video and try to construct a truth table for this statement P and Q and not R and or Q, and then use the truth table to determine the statement given P is true, Q is true, R is false. Alright, now, as we can see here, we don't just have two, but rather three propositional variables. So based on our formula, 2 raised to 3, we will have 8 cases for the given truth values because each propositional variable will have its own truth value and we will have 8 possible combinations for them. So, as a technique, what I would do for the first one is all for true, all for false. Oops, sorry. So there you go. We'll have true, 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 false, 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 false. Then for Q, two true, two false, alternating. True, true, false, false, true, true, false, false. And R will be alternating altogether. True, false, true, false, true, false, true, false. And that specific pattern is actually already giving us all the possible combinations. So there we go. And now we can now go through our specific forms. It's only R that has a not, so I will have a not R here. So I'll just have false, true, false, true, false, true, false, true. Now we can find the other propositional forms. I have P and Q here. So I will have a column for P and Q. So that's true and true, true, true and true, true, true and false, false, true and false, false. The rest have a false here, so I will also have false there. Now, I will now have a not R or Q. Not R and Q. So false or true is true. True or true is true. False or false is false. True or false is true. False or true is true. True or true is true. False or false is false. True or true is true. And then we would now have to conjunct them. So we will now have P and Q and not R or Q. So true and true, true, true and true, true. But the rest will have false, so we'll also have false there. And if P is true, Q is true, R is false, it's the second row actually. We can see that if given that P is true, Q is true, but R is false, the entire statement would still be true. So, let's have another example. We are asked to construct the truth table now for this statement. Not P and R implies Q and not R. The answer to this, and also another one, find the truth value of the statement using truth table given that P is false, Q is true, R is false. The answer will be given in the next video.